So I want to talk about how to solve quadratic equations using what's called the quadratic formula. So if the equation is in the format, in standard form, ax squared plus bx plus c equals 0, you can use this formula. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. And you might wonder why the music notes, why Pop Goes the Weasel. It's just a little tune to help you remember the quadratic formula. And yes, I'm actually going to sing this. It goes, x equals opposite b plus or minus square root b squared minus 4ac all over 2a. And if you sing that a few times, you will have it in your head for the rest of your life. So this is how you use it. So let's solve the equation. X squared plus 12x minus 9 equals 0. So you have to identify the a and b and c. So a is 1, b is 12, and c is negative 9. So we have x equals, the opposite of b would be negative 12, plus or minus square root b squared minus 4 times a times c all over 2 times a. Then the hardest part is just simplifying the square root. So we get negative 12 plus or minus. If you work this out, you're going to get 144 plus 36. So we end up with negative 12 plus or minus the square root of 180 all over 2. Well, now we have to worry about, how do I simplify the square root of 180? So off to the side, you could remember when we did our list of perfect squares, you want to find the largest perfect square that goes into 180, and actually 36 will. So think of this as the square root of 36 times the square root of 5. So you get 6 root 5. So then we have negative 12 plus or minus 6 root 5 all over 2. But you're not quite done yet, because I can factor a 2 out of the numerator, and then that 2 cancels, so, and those reduce to 1. So now my answer for x is negative 6 plus or minus 3 root 5. And that would be our answer. And that's how you use the completing the square formula. It's easy to plug the numbers in. It's a little harder to make sure you simplify it correctly. So the part that's underneath the radical is called the discriminant, and it tells us about the types of roots we'll have. If b squared minus 4ac is a perfect square, then we know we're going to have 2 real rational roots, which also means it would have been factorable. If b squared minus 4ac is positive, greater than 0, but not a perfect square, we're going to have 2 real irrational roots, which means we're going to have a square root in our answer. If b squared minus 4ac equals 0, that means we only have 1 real rational root, which means the related parabola would have its vertex on the x-axis. And if b squared minus 4ac is negative or less than 0, we're going to have 2 complex roots, so we're going to expect to have an I in our answer. So here we're going to start by finding the value of the discriminant. So notice a is 3, b is negative 3, c is 8. So the discriminant is just b squared minus 4ac. So we get negative 3 squared, parentheses are important there, times 4, or minus 4 times 3 times 8. Because you need to make sure, if you plug this in your calculator and you forget parentheses, it's going to tell you negative 9. But we know negative 3 quantity squared is 9. So we have 9 minus 96, which is negative 87. So what that means, we have a negative, so that means I have 2 complex roots. Now it's never a waste of time to find the discriminant first, because when you plug it into the formula, x equals the opposite of b, which is going to be a positive 3, plus or minus square root. We already did b squared minus 4ac, so we don't need to do that again. all over 2 times 3, which is 6. Now, 87 is, cannot be, the square root of 87 can't be simplified, but we do have to deal with the fact that we have a negative under there, so we have 3 plus or minus I root 87 all over 6. Now, you cannot cancel this 3 and the 6 because there's no factor of 3 to factor out of the numerator. There would need to be a 3i or something divisible by 3 in order to do that. So this would be your answer. Next, find the value of the discriminant. So A is 1, B is 8, C is 5. So B squared minus 4AC, we get 8 squared minus 4 times 1 times 5. So 64 minus 20 is 44. So you can look back at that chart. It's positive, but it's not a perfect square. So we're going to have 2 real irrational roots. Okay, so then we go about finding those. So x equals the opposite of b, which is going to be a negative 8, plus or minus square root. We already found the discriminant, so it's a 44, all over 2 times a, and a was 1. So now we're going to simplify the square root of 44. 4 goes into that, and it's a perfect square. So think of this as the square root of 4 times the square root of 11, which is 2 root 11. So now I have x equals negative 8 plus or minus 2 root 11 all over 2. Now this time I can factor out a 2. So I'm going to show you a little shortcut I use instead of actually factoring the 2 out, but that is really what we're doing. I'm just going to cancel out. I'm going to divide the 2 into 8, and it goes 4 times. 2 into 2 goes once. 2 into 2 goes once. So a lot of times I'll do that as my little shortcut. So I get negative 4 plus or minus the square root of 11, and that is our answer. If you have a problem that looks like this, first of all, you would need to have it equal to 0. So I would subtract the 6 first, so you end up with this. But it's sometimes awkward, a little harder maybe, to deal with a negative a value. So multiply both sides of your equation by a negative 1, which means the signs change, and then just go ahead and proceed with the quadratic formula. So hopefully that helps.